And again on the theme here today with ratios and proportions. So yesterday got a little bit of an intro to this with you've got two numbers and we're kind of comparing their quantities. And so not the exact same thing because then we could just put them together and there'd be nothing to compare. But you seriously can compare almost any type of quantity together to make sure that we're good on that front. So, again, we talked about the three different ways you can write out a ratio. You can have A to B, you can have it here, we can even write it this way at times when we need to. But most of the time, this is going to end up being our favorite because we don't get it confused with a regular fraction then, and we don't have as much wordiness as we do with some of the other parts. So if, and I'll just kind of jot this down here for just a sec because I got a couple of you just rolling in here. We're on page 16 in the note packet in case you're just getting here. If we have a ratio of 3 to 5, it means there's 3 units of one thing and to 5 units of another. That could be lots of things. If you're cooking, maybe it's a ratio between flour and water or some sort of a mixture that you're making. And so when we do this, A to B, we're also going to want to have labels. Like these are very generic. Units of this, units of that. We want to make sure we specify what it is so the person looking at it doesn't get confused. So for instance, if we just even rolled with today, okay, with what we got in class, let's say in here right now, we've got one teacher, okay, 2, 3, 4, 5, 6, 7, we're going live here, 8, 9, 10, 11, and 11 students. So our ratio would be 1 to 11. 1 of me to 11 of you. So if somebody was trying to say, well, we wanted to keep that ratio, but we need to put more students in the class because we don't have room. So then we could go up to like, hey, if I had 2 teachers, how many students would I have? And we can figure that out with a proportion. But it all starts with a singular ratio. So, as we kind of take a peek here onto the back, these are going to look a little bit more like what we're going to be doing with our problems. Holy cow, this is huge. Okay, but that's all right. So the nice thing with our note things today is everything's kind of here. We can just kind of take it in and add some more stuff if we want to. So we're planning a pizza party for a math class. Not a bad idea. Since they all did so well on the last exam, she wants at least 2 pieces per student. She has 28 students in her class. Show and solve as a ratio. Now, do I need to necessarily write out, this A, B, C, D that we see here every time? Not necessarily. We're more interested, even though we want to know what the parts are. So we want to put pieces compared to pieces. So here's what I mean by that. I'm just going to kind of rewrite this up here. So if I have 2 pieces per 1 student, we can make it a fraction type form. We'd have X pieces of pizza. Oh dear. I needed to start a little further over, didn't I? For 28 students. This gives it a little bit more of a mathematical look with the labels so we can kind of see why things go where they do. We notice all the pieces are on the same level and all the students are on the same level when I make my proportion. We always have to make sure of that. Otherwise, this can get screwy. Like if I had put the 28 on top and the X on the bottom, that would have been majorly different from this, and everybody had probably gotten less than a piece of pizza, and that wouldn't be very good. So That's where this is coming from. And once we get here, again, as we do with proportions regularly, does it matter which side is which with these? It really doesn't. So we got 2 times 28 on this side, which is 56. We got 1 times C on this side, which is 1C, or just C. And so we find out we would need to order 56 pieces of pizza, and depending on the place, I know they're not mentioning this in here, and again, we're over on page 17 in the note packet. Let's say there were, 8 pieces in a pizza. That'd be a whole nother proportion that Mrs. Turtle would have to do to figure out how many pizzas she needs to order. But that's where you can actually use these things in a real world situation to kind of figure out, hey, how is this going to set up? So, I think I got, yep, one more of these, then we can get into the real ones and do it ourselves. Hey, what a coincidence. Mrs. Turtle, she's back again. No, she needs 56 pieces of pizza for her class. Okay, we just figured that out in the last one. She calls the Pizza Shack and discovers one large pizza has 12 pieces. That would be kind of, man, those would be small pieces. How many large pizzas does she need to order? So we're back again, making sure that our pieces, 12 pieces in one pizza, but she needs 56 pieces, and we don't know how many yet. Pizzas. Again, keeping the same type of thing on the same level when we're setting up our proportion. And so just like we did on the first one, it becomes a cross multiplying game. But here's where the more real world part comes into this. So, does the math, goes ahead, divides the 56 pieces by 12, because there's that many in a pizza, and gets 4.666666. Okay. Well, as it says down here, and I wish I would have blanked this out instead of just leaving it, you can't order 2/3 of a pizza. I guess you could try ordering a smaller one. Probably not. So you'd have to, in this case, round up. You're going to have to order an extra pizza. You'll have a little extra for later or something like that. So that's one thing with these. The exact answer you get at the end may not always be the answer that you're looking for. So we got to kind of keep an eye on that to make sure that we're doing okay. So here's where we're going to kind of bring this into play. So I'm going to move this to the side for a moment and move over to the practice packet. And I'm going to go a little out of order today. Because some of you may be going, wait a minute, like we're skipping whole pages in here. I'm going to use those pages later. I'm just kind of making my order a little different. I'll be back to 18 in a minute. That's going to be my review. The next group of pages, and I want to make sure I get to the right ones. That's why I'm doing this. 24, I believe, off the top of my head is the number. It is. Okay. There's a problem on each page. So it's not like this is going to drive us too insane here. So here, set up pretty much similarly to what we were just doing on the other ones. So we got, if 1 out of 10 people are left-handed, how many left-handed people are in the school out of 360? Now, I have a couple of confessions I need to make here. So when we're setting these up, okay, sometimes they may be worded in such a way that you're like, Hardy, I could do this in one step right now. I know what I want to do already. But it may not always set up that way, is going to be what I'm kind of looking at here. So when you're doing this, I'm more of a fan of going straight into the proportion, even though we can label things. So here I look, I'm like, okay, so 1 out of 10 people are left-handed. So one left-handed out of 10 people. And I'm like, okay, so what other information do I have? How many, that's going to be my variable. How many left-handed people, we don't know, so we're going to, you can use any variable you want here. If you wanted to use C or D, whatever that happens to be. Out of 360 people. So again, notice when we make our proportion, when we make our comparisons, all the left-handed people are on one level. Okay, all the just people in general are on one level. So once I have that, I can do my cross multiplying. So 1 times 360 is 360. My cross multiplying the other way. And then we just have our one step to solve. And I know some of you would look at that and go, well, Hardy, I know I just got to do 360 divided by 10 and I can figure it out that way. This is more about just figuring out the process. And also, learning about making sure that we label things well. Because if I just put the answer is 36, you're like, okay, 36 people, 36 hands, 36. Let me go back to the last problem because I'm thinking about it now. 36 pizzas. We don't know if we don't label things. But again, lots of room here to be able to work with it. We don't necessarily need that much room, but it's always nice to have a little extra rather than not enough. So the problems on 20, 21, 22, 23 are similar in setup. 24, you get to create your own. So what I'll probably do with that is, because we tend to come back to things as we do the cycles, I might start stealing some of your questions, putting them on future quizzes here. So come up with something good here so we can find that for you. And if I use it, I think we'll have to put just some extra points as well. So think carefully on that front. But for the moment, I'm going to go backwards for just a sec here. This is going to be my way, as we go backwards to page 18, my way of kind of reviewing a little bit with you of what we were doing yesterday, or hopefully with the lessons you looked at yesterday, what you may have picked up from that. So here on the back, we're going to be setting up some ratios, but we're also going to be chatting a little bit of proportions. So I think what I'm going to do, I'm going to run a few of the odds with you, and then I'm going to leave you some of the evens. Always want to make sure on weekends that we got you in good shape here. So a tight end scored 8 touchdowns in 14 games. Find the ratio. So we're not doing a proportion. It's one fraction of touchdowns per game. So when we have this is telling us the order of our ratio or our fraction. Then we're putting the touchdowns first, and we're putting the games second. Now you could put 8, 2, 14, 8, colon 14, but the question then becomes, and I forgot my calculator, so I'm going to grab one, is can I simplify the fraction? Because we're always looking to do that if it's possible. So let's turn this up a little bit. And again, these are equivalent to a fraction. Okay, those tell me the same thing. So let's see with a little math enter. Okay, so this would be 4 to 7 would be my most simplified form of that. And I just like putting the labels with, just so I can kind of see what things mean. So not going to be anything too bad there. Okay. Ratio, all right, let's see here, of the first to the second. So the length of the pickleball racket is 1 feet 4 inches, and the length of the table tennis paddle is 10 inches. Ooh. Okay. So here, this gets a little more interesting because we've got different measurements that we're working with. So here, 1 foot 4 inches. How many inches are there in a foot? 12. So here I got 12 inches plus 4 inches. So I got 16 inches here actually, because we got to be in the same measurement if we're going to do a ratio. So once I have that, it's not as bad, because now I'm like, okay, so the first measurement is 16 inches. The second one is already totally in inches. That's 10. And then again, since everything in inches, if you were going to label, you could be like pickleball racket to table tennis paddle. Some of us still call it ping pong. To make the ratios, okay? That's how much they vary in size. So the pickleball one's a little bit longer. Ooh, 5 and 9. Okay, perfect. And then we should be good. The lengths of the sides. This one showed up a couple of times yesterday. The lengths of the sides of a triangle are in the extended ratio of 3 to 5 to 7, and its perimeter is 450 degrees. So the length around the outside, which we'll talk more about in depth in the next part of our cycle. Find the measure of the longest side of the triangle. Okay, so yesterday we put X's with each of these, and we know that perimeter is add. So my 3 sides of my triangle would be 3x, 5x, and 7x. And they add up to 450. And all those x's, all those sides are like terms, so we can go ahead and put them together or add them. No opposites this time. So 3 and 5 is 8, and 7 is 15. And let's see here. Now, here's the thing we have to be careful of. Normally when we do algebra, once we get x, we're done, we're happy, that was the goal. In this case, though, it's not. Because if I look at that last sentence, find the measure of the longest side of the triangle. The longest side is going to be this 7. So my longest side would be 7x, but we know what x is now. X is 30. So don't be content just getting to the end. Make sure, hey, I might need to figure out something else besides just what x is for once. And in this case, that's what we needed to do. Okay. One last one coming from me, and then I'm going to kind of have you try the rest of them out here. Ooh, even though I do see one thing I'm going to help with on number 4 before we wrap up. Solve the proportion. Okay, sometimes when you have a proportion, we're doing the cross multiply thing. If you ever see a plus or a minus and the parentheses aren't there, you need to put them there to make sure we do this correctly and we don't forget to distribute. Because when we cross multiply,
I thought you said 8.
We can do them in either diagonal order. If you did the 8 first with the n, that's
You said 8 problem.
Oh, I did. Well, that's no good. I'm trying to do number 9 here. Man, I'm having all sorts of issues getting into the kick of things here this morning.
I didn't have breakfast this morning because I accidentally woke up at 7:33.
Oh, dear. Well, I'm glad you got here. That's awesome. That's a good thing. So once we're cross-multiplied, this is why we needed to make sure we had the parentheses. Because we got to do the 4 times the n and the 4 times the 4. And now I have a choice. I have n's on both sides of the equals. I don't want to have n's on both sides of the equals. I got to get them together, so we got to do an opposite. This is just me. Since this side with the blue only has n's, I'm going to move all my n's to that side so I don't get confused and not have anything on one side. So move that up a little bit here. And then what's my last step going to be? Yeah, we're going to divide. And get to my answer there. So a little bit of a mixture of things as far as that goes. But the one last thing, and I'm not going to do the whole problem, but I just want to make sure we're good. Number 4 is similar to number 3 in that we've got these different measurements of the pickleball and the ping pong ball here, except here's the thing. Once again, they don't have the same measurement. Like before we had feet and inches we were mixing together. Now we have millimeters and centimeters. I guess we could go either direction with this, but I think it'll be easier to turn centimeters into millimeters. Anybody happen to know what the difference is, like size-wise, between a centimeter and a millimeter? That's one you made.
Millimeter is a little bit longer.
Just the other way. Once
Means small.
it does. So like if you had a millipede, so centimeter versus millimeter. For every 1 centimeter, you have 100 millimeters. So if that's true, and we're going to leave this alone, we're going to turn the centimeters.
400.
That's right. And then we'll be able to make our ratio because now they're in the same type of thing. You could do it the other way, but we would have had to divide that by 100. Now we're getting decimally, and that's not as much fun when you're trying to deal with stuff. How would we do 7? All right. So here, ooh, good question. Okay. The measures of the angles of a triangle are in the extended ratio 4 to 3 to 2. What's the measure of the largest angle? Okay, I need help. How many degrees are there in a triangle? Close. 180. So there's 180 degrees in a triangle. So now you've got your value to be able to set that equal to, kind of like what we did up here with the perimeter. Yeah, a little bit of information we needed there. Good question. Excellent question. So again, your job here, for the finish here, is to finish the ones here on page 18 and then play with those single problems on 19 through 24, including creating your own practice problem over on 24. As always, if you need any assistance, let me know. We got keys online and up front, except for the problems that you're creating, of course. And that